Alright, what we have here is Mat090, factoring by grouping, or actually just grouping. The right way to look at this problem here is that you have the x squared minus 4's appearing twice, once in the front and once in the back. What you can do with this is you can take the x squared minus 4's and make them into one grouping, and then you have in the front the a and the b, which become the first grouping. So in front you have the a and the b, and then in the back you have the x squared minus 4. Now this is grouped like this because there's an addition sign in the middle. So you can see it would be different if there were a multiplication sign in the middle. This would be an entirely different operation. But when you have the addition there between the first set of factors being multiplied and the second set, that's why the second x squared minus 4 becomes one thing. It's like combining ax plus bx. The x's would just be 1x. So you have a plus b times x squared minus 4. But we're not done here yet because the x squared minus 4 can be broken down and it can be simplified into x minus 2, x plus 2. Now there is a way that's broken out. You actually have to see this. You have to know that this breaks down into that. It's just one of the things you have to automatically learn to look at to know that that's the way it works. There's a wrong way to do this when you get to this point. It's where people would try to redistribute all the parts, like the a back into the x squared minus 4 and the b back into the x squared minus 4. But you create a bigger problem that you would have to regroup in a different way. So there's not actually the right way to do that. Part here on the bottom left, that would be called the prime form or the completely factored form, because it can't be reduced or factored anymore. But the part on the right is actually more of a problem, more complicated. It hadn't been simplified, it had been more complicated. So our next problem here, and these are more, the first one it was drawn out, and these are more straightforwardly presented. You have the part in the back there again, the x minus 2, repeats twice. So you can see then that becomes one of your factors, and then in the front you have an x squared minus 1. The reason that there's an x squared minus 1 like that is the x squared comes out from the front, but there's a minus 1 invisibly in the second part. You can see where the arrow there points to the minus 1. That negative side always has the 1 in front of it. So you get the x squared minus 1, but then that reduces into x minus 1 and x plus 1. Again, we have another problem here. It's a repeat of the same style problem. This one is a little trickier. It's not the same. It's not presented the same way because it's not been completely factored in the 2x minus 2 part. Actually, a 2 can still come out of there. So you can see that in the front part, the 2x minus 2, a 2 comes out, and in the back part of the 2x minus 2, a 2 comes out. And now you multiply those in front by the 2a, and then in the back by the 2b. It's a little of a trickier problem. You have to be able to remember to see that. It's almost like a puzzle. The a and the b seem like they were already taken out, and then this is what you were left with to work with. So you would combine the first two, the 2a plus the 2b. And then the backs, again, because this is a plus in between these two, there's a plus in the middle of this problem, not a multiplication. You can combine the back two parts as if they were just like an x. So what's left then in the backs is x minus 2 and x minus 2. Let's look at that whole thing is just like it's just an x. If you had 2ax plus 2bx, it would just be then 1x. So in the back you have the x minus 2 and the x minus 2 combining. So your new problem is 2ab times x minus 2. But again, now for the second time, a 2 can come out. The 2a plus the 2b, again, a 2 comes out of there. And that, by itself, the 2 stands in front, so that it's 2 times a plus b times x minus 2.